let's talk about the vector equations of a line. So we know there are multiple ways to represent equations of a line in both 2-space and 3-space. The slope y-intercept form, your scalar equation, vector equation, and parametric equation. I'm going to talk about the vector equation of a line and give 2 examples of what you can do with that form of the vector equation. And we're going to use those examples in 2-space. So the vector equation is represented by xy equals x naught y naught plus t a b. Okay? This means that x naught y naught is a point on the line. This can be any point that falls on the line, meaning you may have the answer to a question where your direction vector, AB, is the same, but the point is different. As long as that point lies along the line, that is a vector equation for that line. V is the direction vector. And this determines what direction the line is going. And t is a parameter. Okay? It remains a variable. This is a scalar value that's an element of all real numbers. You can plug any t value into your final equation, and you'll calculate any point on that line. This is what can be used to calculate any point on the line given an equation with a point and a direction vector. Let's look at the examples. Example 1. Determine the vector equation for a line that passes through the point 2, 1 and 5, 7. Okay, so they give us 2 points. We need to have the point and a direction vector. Through these 2 points, we can calculate a direction vector. We learned that in the previous lessons. 5, 7, and 2, 1. We can go 5 minus 2 and 7 minus 1 to get our direction vector. We'll call it B. 5 minus 2 is 3, and 7 minus 1 is 6. This is our direction vector, because this will be the calculation from moving from one point to the other. So, our answer, we can choose either one of these points. I'm going to choose 2, 1, will be our vector equation of the line is xy equals 2, 1 plus t times 3, 6. 2, 1 being any point on the line, 3, 6 being the direction vector. Let's look at the second example. Find the vector equations for a line perpendicular to this line that passes through this point. Okay, the key here is perpendicular. This means that we have to look at this line and find a direction vector perpendicular to the one that's given. If our direction vector for our one line is 5, 4, we can use the dot product to figure out what's perpendicular. I'm going to let our direction vector equal xy. Therefore, our new direction dot our old direction vector should equal 0. Because for the dot product, when 2 vectors equal 0, they are perpendicular. Let's do the dot product. This means 5x plus 4y equals 0. This means that any value for x and y that satisfy this equation, that will be a direction vector that's perpendicular to this value. Something we can use could be something like 4 and negative 5. So let's say let x, y equal 4, negative 5. Then if we plug these values in, it would equal 0. There are multiple answers for this. Choose one that works. This is our new direction vector, 4, negative 5. And it passes through the point 7, 4. So our final answer is xy equals 7, 4, the point that passes through, plus our parameter t times the direction vector 4, negative 5.